Hello, hello students. Now we will be moving one step ahead. Like in the previous video we had discussed, due to a point charge, we had determined the expression of potential at a point, say at distance r, right? Then we had found that the expression of potential at any distance in the field of Q is given by the constant, the field factor and the distance. Like now, if in a system, if there are more than one charges, point charges, okay, then what will be the potential? Okay, then if I call this one q1, then what will be the potential at this point? V1. Let's say the distance is r1. Okay, now in the system, apart from q1, there are other charges, say q2, say q3, q4, qn, so many. Okay, and let's say this q2 is at the distance of r2. Okay, and qn is at the distance of rn. So similarly, let's say q3, q4 are at the distance of r3, r4 respectively. Okay, then what would be the potential due to q2 at this point p? Then the potential will be what? Q, this is q1, right? This is due to q2 at the distance of r2, right? Based on that expression, previous expression. Similarly, potential due to qn will be what? This is qn rn, right? Now, what is the total potential at this point P? The total potential at this point P will be due to Q1, due to Q2, Q3, Q4, Qn, right? So the total potential will be due to 1, due to 2, due to 3, due to 4, and due to n. Now, one good thing, potential is a scalar quantity, so this will be what? Direct addition, no vector overhead, right? Then this one, if you remember it, then whenever a question comes where there are more than one charge is involved and you have to find out the potential at some point, this consideration you have to make it. Okay, now based on this, so I think this is clear. Now I will go to dipole. Can I get the duster? Okay, this one will work. Okay, no, it's not working. All right, now let's take a case of a dipole. All right, dipole is very common, right? Because we are dealing with polarization and charge induction. So dipole is a very important topic. Dipole on axial line. Okay, on axial line, what we are finding the potential? Let's say here is a dipole, minus q plus q, system of plus and minus q, equal and opposite charges separated by some distance. This is an origin, the origin length L, right? As we are taking, so distance is double L. Now axial line means the line joining the two charges, right? It can be on this side also. Let us find out the potential at this point P. Let's say this point P is at the distance of R from the origin. Then what will be the potential at this point? Total potential will be what? Due to minus Q and due to plus Q, right or not? Right? Okay. Now due to minus Q, what it is? 1 by 4 pi epsilon naught Q by, due to minus Q, what is the distance? R plus L. And okay, now potential is a scalar quantity. If the scalar quantity we are dealing, then we have to put the sign of the charge. Okay, if the quantity like electric field, if it is a vector quantity, then you shouldn't write the sign. Okay, as potential is a scalar quantity, that's why we are writing the sign. Okay, one point to remember. Then this will be what? 1 4 pi epsilon due to plus q. What is the distance? This is r minus l, so q by r minus l. Okay, now you do the plus minus and simplification, then you should get I have already given in the notes also. You should get 1 by 4 pi epsilon P by r square. Okay. For the dipole electric field, if you remember, what was it? Electric field was, I'll put in terms of vector, what was it? 1 by 4 pi epsilon 2p by r cube. All right. See, even in the potential, due to a point charge, what was that? That was kq by r, right? Electric field was kq by r square, right? Similarly, in the potential, when r square is involved, for the dipole on the axial line, r cube is involved. So this way it will be easy to by heart, I consider. All right. Similarly, let's go on the axial line. Sorry, equatorial line. Okay, we'll quickly see this one. Equatorial line, right? Okay, equatorial line, I'll quickly do this one. Minus q plus q, origin is O, perpendicular bisector line is called what? Equatorial line. Now let us find out at this point what will be the potential, right? Now this is the perpendicular bisector. If I join this two triangle, the two triangles will be what? Congruent triangle, because this side is common. The two sides are what? 90 degree, and this two sides. That means what? The two triangles are congruent. That means what? This side and this side are the equal in length. Then what is the total potential? Minus q plus q, right? It is a scalar quantity. No need to be confused about the directions, right? Then what is the potential? This is k minus q, right? And what is the distance? Whatever the distance, let's call it x, right? And another will be what? K, q, what is the distance? If it is x, how much it need to be? X, right? So minus q, you see what? On the equatorial line, the potential is what? 0, right? Now, can we, if this is a dipole, this line means, can I consider like a plane, right? On this plane, on the equatorial plane, what? There is 0 potential. All right. Now, what will be the consequences? In the next section, we are going to discuss it. Okay. Thank you.